So chapter 6, section 1 is called angles and their measure. We are going to learn how to take something that we're normally used to putting in angles, and we're going to figure out what it's like in what's called radians. So a radian is the measure of a central angle that intercepts an arc equal in length to the radius. So the arc length, which would be the outer ring, is the same as the radius. This relies heavily upon what we're going to get into. It's called a unit circle, in which the radius would be 1, but the radian itself doesn't have to have a radius of 1. It just has equal arc length. So if you think about arc length from geometry, the arc length is like the crust of the pie, okay, the outer ring. So the first thing we're going to figure out is this is arc length, okay, and I use this formula just because I think it's easier to remember. They're both the same thing, but S stands for arc length. Don't ask me why. There's not a single S in the word arc or the word length, but S stands for arc length, okay? And in geometry, you did it as the measure of the arc over 360 times the circumference, which is 2 pi r. That's one way to measure it. We're going to have different information now. God bless you. You're going to take the measure of the angle that forms that arc, so the central angle, which we call theta, and you're going to multiply it times the radius. Now, one of the most important things is that theta has to be in something we call radians. So a radian is just a unit of measure. An angle is either going to be in degrees or it's going to be in radians. I'm going to teach you how to convert back and forth between the two, okay? And we're going to learn about the angles around our unit circle in both degrees and radians. So we talked about it in degrees already, but today we're going to do a little bit in radians, and then tomorrow we'll get heavy into that unit circle. So it says 1 revolution around a circle of radius r corresponds to the angle of 2 pi radians. So if I go all the way around my circle, this whole arc length is 2 pi, which is the same as 360 degrees. So a full circle, if you think about a full circle, the circumference would be 2 pi r, right? You remember circumference, 2 pi r. If it's got, if my radius is 1, then my full circumference is 2 pi. So all the way around one full circle, the measurement is 2 pi. Sometimes you will see it left, like 2 and pi. You'll keep it in terms of pi. And sometimes you'll actually see it without pi, in which we would approximate that to be 3.14, and that would be 6.28. So sometimes radians has pi in it, like 2 pi, and sometimes it actually multiplies that pi out as 3.14. And so the full, all the way around the circle's measure would be 6.28. Yeah?
How is circumference 2 pi r and 2 pi?
If r is 1. So we're saying that the radius would be 1.
Oh, in a unit circle.
Right, yep. So if I had tried to find, let's say, halfway around my circle, and I'm in radians, if from 0 all the way around is 2 pi, what's halfway? Pi. So like this measure here, which is usually 90 degrees, is actually pi. If I express it without pi, I also can approximate it as 3.14. Those are the same things. So those would be radian measures. How about a quarter the way around my circle? 1/2 pi, which would be pi over 2. And that's where 90 degrees exists. And then at the bottom, 1 1/2 pi would be 3 pi over 2. So remember I said it was important to learn the angle degree measurements at that. So let's write those in so we remember them. This is 0 and it goes all the way around to 2 pi or 360. This is 90 degrees, which is the same as pi over 2. This is 180 degrees, which is the same as pi. This is 270 degrees, which is the same thing as 3 pi over 2. And then we go all the way back around to 360, which is the same thing as 2 pi. So today, we're going to do a lot of like conversion between the angles and the degrees so that you can figure out where these angles exist, because you're going to get questions like what quadrant does this angle lie in? And you've got to figure out where it would go. But tomorrow, we're going to add in some special angles. So all those special angles that we know, the 30, 60, 90 angles in every 30, 45, and 60 angles in every quadrant also has a special radian measure. So we're going to add those in tomorrow. But for today, One of the things we're going to do is find arc length. Another thing we're going to do is convert between radians and degrees. And we're going to find coterminal angles in radians. So if you think about how we found coterminal, how would I find coterminal if it was in degrees? Good. Add and subtract 360 degrees. We just said 360 is the same thing as 2 pi. So if my degree measurement is in radians, all you have to do is add or subtract 2 pi. You can convert it to degrees, add and subtract 360, but then you got to convert back to radians anyways. So it's just easier to add and subtract 2 pi. So if I had, so from each of these, I'm going to add and subtract 2 pi. Pay attention to directions. If it says in between 0 and 2 pi, then you know you have to keep it like at the 5 pi over 6 would be your answer. If it says in between negative 2 pi and positive 2 pi, now I can include negative 7 pi over 6. If it says, excuse me, if it doesn't give you any kind of specific range, but it says positive and negative, you can have the negative one that's there, the negative 7 pi over 6, and then either of those positive ones. So if it's not specific, then you can have multiple answers. All right, so if I look at 2, if it had said find a coterminal, find a positive coterminal, I would want to do what? Add 2 pi. So again, I give it a like denominator. This time it's got to be over 3. So negative 4 pi over 3 plus 6 pi over 3, and I get 2 pi over 3. If it had said negative, I would have subtract. And if it wasn't specific, you can get multiple answers. All right, this is how we convert from radians to degrees or degrees to radians. So if I'm going from degrees to radians, I take my theta, which is just your angle, and you multiply it times pi over 180. Usually these radians have pi in their answer, but not necessarily all the time. Okay, if I just said 2 without the degree symbol, that is 2 radians. So a radian doesn't have to have pi. If I'm going to go from radians to degrees, I take theta and I multiply times 180 over pi. And again, usually that means we eliminate the pi, but you don't have to. When you are writing these two forms, your degrees has to have the degree symbol on it. If you don't put the degree symbol on it, you're implying that's a radian, okay? So radian doesn't have to have pi, but degree has to have degree. All right, so it says convert the angle, and it says and, but it should be angle, from degree to radians or radians, from degrees to radians or vice versa, which would be the other way around. So if you look at 3, is that in degrees or radians? It's in degrees, so I'm going to multiply by what? Pi over 180. So if this was on, if this test had multiple parts, this would be on the non-calculator part. You'd want to simplify this. So 5 goes into here 27 times. 5 goes in here 36 times. 9 goes in here 3 times. 9 goes in here 4 times. And I get 3 pi over 4. I go to 4. This is again in degrees, so multiply times pi over 180. This time I can cancel through my zeros, make it a little bit easier. What goes into both 54 and 18? 3, so this would be 6 and 18, and then 6 goes in here and in here 3 times. This is 3 pi. God bless you. 45 times pi over 180. What goes into both 45 and 180? 9. So this would be 5 and 20. Wait, did I do that right? No. Yeah, and then 1 and 4. Yeah. So this is pi over 4. So 45 degrees being pi over 4 is important. You'll learn that a lot. You're going to see it a lot. You can. You just don't need to. Yeah. And on the unit circle, you won't see it like that. But that's not wrong. Yeah. Okay, 90 times pi over 180. 90 goes into 180 2 times. Remember, we said those are the same. Those would be the angles at the top. Pi over 2 and 90 degrees. Good so far. All right, now we're going the other way around, and I know that only because there's no degree symbol, okay? So 5 pi over 6 would be times 180 over pi. 6 goes into 180 30 times, and the pi's cancel. And I get 150 degrees. You have to put the degree symbol on it. Eight, again, that one's in radians, so 180 over pi. The pi's cancel. 4 goes into 180 45 times. And I'd get 3 times 45, which is 135 degrees. Okay, 9 is negative. It stays negative. So that negative has no bearing on what I do here. I'm going to multiply times 180 over pi. But we should know this in reverse, right? If pi's cancel and 2 goes into 180, that's 90. But it would be negative 90 degrees. So if the radian is negative, then the conversion is negative. That doesn't change anything. All right, so 10 and 11, and this is what will throw people. Those are numbers. They don't have pi on them, but do they have a degree symbol on them? No, so these are radians. So we're going to multiply times pi over, 180 over pi. You can't cancel anything this time, so I would do 180 times 5, and I get 900 over pi degrees. If the question said to keep it exact, I would leave it just like that. If it says, which I think the homework says, round to the nearest hundredth or whatever it is, then you're actually going to use your calculator. And you're going to use the pi button on the calculator, not 3.14. So if you're going to approximate, then you would use 3.14. But if you're going to actually use the calculator and you're going to round, you're going to use the pi button itself, which is above the little caret button on the graphing calculator. So this should be 286.48 degrees. Homework actually says 3 decimal places, so it'd be 286.479 degrees. Just pay attention. I think it'll tell you on each question. So right now it doesn't matter what mode this is in. It doesn't matter until you hit sine, cosine, or tangent. But you are going to have to switch back and forth between the two. You'll see that when we get, I think tomorrow when we do the trig functions of an angle, you'll see that, yeah.
Does it matter where we put the degree? Like if we put the degree on the pi side, would it be different?
You mean for this? Yeah. Like that answer? No. I would just say, I don't know if WebAssign would take that. I would just put it all the way on the outside. Yeah. Okay, so then 11 is 2, and again, that is not 2 degrees, that is 2 radians, so we would take that and we would multiply it times 180 over pi, and I'd get 360 over pi, and if I was to round that, 360 divided by pi, I'd get 114.592 degrees. So part of the assignment for today is going to ask you to pick the graph of these angles, and they're going to be in radians. So if I had something like pi over 2, okay, you kind of have two choices. One, I would say get to know pi over 2. We know pi over 2 is 90 degrees, okay? If you don't know it yet, we're going to get to know it. But if I wanted to graph something like that, I'd start with my initial side right at 0, and it would stop at the 90 degree mark, and that would be pi over 2 or theta. Now, the more obscure these radians get, like you might get something like 7 pi over 6. And that's not as obvious yet. It's going to be, but it's not as obvious yet. You can take something like that and convert it to degrees and then graph it using that. So I could do times 180 over pi. The pi's would cancel. 6 goes into 180 30 times, and that's 210 degrees. And then I would start at 0. Remember, this is 0, 90 degrees, 180 degrees, 270 degrees, and we double back around to 360. So I would start at 0, and then I would go all the way around past 180, and that would be theta. So that's one way to do it, is take it, convert it to degrees, and then draw it. There are going to be ones that are bigger than 360, so you can subtract 360 to find the coterminal. You're going to go around your circle more times. There's going to be negatives. You're going to go in the other direction. Like everything we did with the original graphing in section 1 from chapter 5, you're going to see again like that. And then it will say like what quadrant it is in. This would be in quadrant 3, okay? Another trick to doing this is to learn the radians. So if I, which you're going to eventually want to do, okay? If I were to take 7 pi over 6 and convert it into a mixed number, what is that? What's 7/6 in mixed number? 1 and 1/6 pi. Where was 1 pi, or where is pi on this circle? 180. So this is just pi. So that would be if my answer was just pi, right? 1/6 past that puts it right into the next quadrant. So that's the other way to do it, okay? And again, right now we're kind of getting our feet wet with that convert. So feel free to convert it, graph it. But when we get to tomorrow, we're not going to convert anything. We're going to go straight into figuring that out, okay? It will make your life a lot easier. So if I had 11 pi over 6, and I convert that to a mixed number, it's what? 1 and 5/6 pi. So the 1 says I'm all the way over there already. This would be 1.5. Is 5/6 bigger than 1.5? Yep. So I would go past it. It's not quite 2 though, right? Because this would be 2 pi. So that would put it in the 4th quadrant. You could also, for today, take 11 pi over 6, multiply it times 180 over pi, cancel out your pi's, 6 goes into 180 30 times, and I'd get 330 degrees, which is in the 4th quadrant. So for today, do what you're comfortable with, but know that we're moving towards that conversion, okay? So when you are converting it, we're moving away from the conversion. When you're figuring it out, you want to remember that it's 0. It's 1/2 pi, which is pi over 2. It's pi, or 1 pi. It's 1 and 1/2 pi, or 3 pi over 2. And it's 2 pi. So each of those angles will either fall on one of those axes, or it's going to fall inside those quadrants.
So you said that we didn't have to know the second way, but we had to know the first one.
For today, you can stick to converting and graphing it and drawing it. Yeah, like in the homework, it's going to say draw 17 pi over 3, and you've got to know where it is.
Okay, and we don't have to convert it to...
Not. Oh, no, I would say today's method is converting it to degrees.
No, I mean like converting it to a mixed number.
Correct. Yep, we will do that more tomorrow. But eventually, I know it seems weird right now, it will make your life so much easier than converting something like 12 pi over 5 to degrees, and then it's coterminal, and then you got to find it. Like, I'm going to teach you a couple tricks to do that without having to convert it to degrees. Yeah. So for the whole number radians, like if I have my full circle, right? For the whole number ones, not the ones that have pi in it, but the whole number ones, right? So if I took, and this starts at 0, and then we said this was pi, this would be 3.14. And then we would double back around to 6.28. So if you were looking at them in terms without the pi involved, that's what they would be, right? So a lot of times you'll get like 1, okay? And you want to figure out where 1 lies. It doesn't have to be exact, but if you think about it, if halfway across your circle, oh, that's so crooked, but you understand the point. It doesn't look crooked to me. Halfway across the circle is 3.14. That means like from here, it'd be about 3. So if I wanted to find 3, it would be there. Like that angle would be 3, okay? And then that means that if I take from 0 to 3 and I divide it from this section here, if I divide this 2 more times, that's going to be 1 radian and 2 radians. So this-ish and this-ish, that would be 1 radian. That would be 2 radians. And if you make lines out of what we just did, you get the other parts, which would be 4, 5, and 6. So if you're approximating where it goes, that's where you could do your whole number ones. And if it's negative because there's one that was negative, go the other way, okay? Remember, negative, you can either go this way, or you can find where it's positive and fold it, and it'd be where it overlaps. So if it doesn't have pi, if it's a whole number one and it doesn't have pi, that's one of the tricks you can use. If you wanted to know what it was, you would literally take pi and figure out what pi is without the symbol, which is that 3.14. If you wanted to know what 2 pi was, you would do 2 times 3.14, which is 6.28. There's not a lot of this, so I don't want to spend too much time on it, but I think that's easier for you to understand instead of having to convert it and then find it from there. All right, so the last two things, and one is kind of what we did at the beginning, are arc length and area of a sector. So when you do these in geometry, it's different. In geometry, we get an angle, we put it over 360, we multiply by the circumference or by the area. When we do them in trig, the theta is already your angle over 360. So it's already in radians, okay? The arc length, which again I said is S, would be theta times the radius. I like that formula in that method because I remember it as SOR. So like the O kind of being your theta, S-O-R. SOR is your arc length, okay? And then the area of the sector gives you like the area of that piece of the pie, so that whole space. So the arc length is just the outer ridge or the crust of it, okay? And then the area of the sector is that whole piece of the pie. And that would be 1/2 r squared times pi, or r squared theta over 2. You could do that in either, like you can either multiply by half or you can divide by 2. Those are the same things, okay? But again, in both of these cases, theta must be radians. So if they give it to you in degrees, your first step is convert it to radians and then plug it into your formula. You're going to get given like theta and you'll get given the radius and you'll ask for the arc length, or they'll give you the arc length and theta and you're finding the radius. So you're going to get given 2 of those 3 things and you sometimes have to work backwards to solve the other one. But those 2 formulas are need to know formulas. The conversion today would be the first one, and then the arc length and area of the sector. So this says a circle has a radius of 18.2 centimeters. Find the arc length and the area of the sector with theta being 3 pi over 8. So my arc length is that SOR, and the area of the sector is 1/2 theta times r squared. So the arc length, I need theta, and this is already in radians. So I just plug that in, 3 pi over 8, and I multiply it times 18.2. So on homework, it says round to 2 decimal places. If this was on a portion of your test that did not have the calculator, you would keep it in terms of pi. So you would leave pi there and you would just multiply 3 times the 18.2. But I'm going to multiply that out. 3 times 18.2, and you can do 3/8 times pi times 18.2. And I get 21.44. This unit is centimeters, and because it's arc length, it's not centimeters squared, it's just centimeters. So you could have done 3 times 18.2 divided by 8 and then times pi. You could do that in any order you want because it's all multiplication. You'll get the same answer. Yep.
So where did the 1/2 go?
That's not on the radius. I'm sorry, that's not on area. That's not on arc length. That's on area. So that's the second one. So the second one says find the area of the sector. That's where the 1/2 comes in. 1/2 theta, which is 3 pi over 8, times r squared, so 18.2 squared. And again, this is multiplication, so you can do that in any order. Just be careful. Make sure that 18.2 is the only thing being squared. So I do 0.5 just to not have to do the fraction. 3 pi divided by 8 times 18.2 squared. Group this. And you get 195.12. This time it would be centimeters squared. Questions on that one? Yeah.
Mine's not giving me like an answer. It's putting it in.
All right, last example says a circle has a radius of 18.2 with theta being 144 degrees. Find the arc length and the area of the sector. So what's the difference between this one and the last one? This one's not in radians yet. So I have to take theta and convert it to radians. So I multiply times pi over 180. If this was kept exact, then I would continue to simplify this. Okay, I could start with 2. This would be 72, and this would be 90. 9 goes in there. This would be 8, and this would be 10. So this would be 8. Well, even further. Hang on. 4 and 5. So this would be 4 pi over 5. That's one thing, okay? If it was kept exact, you would need to do that. And then I would do S equals theta times the radius. So 4 pi over 5 times 18.2. And then if it's kept exact, I just do the 4 times the 18.2, 72.8 pi over 5. If it's kept exact. If it's not kept exact, and I think the homework, they all round. If it says to round to nearest hundredth, then I can literally take this as even part of my equation. I can do 144 times pi over 180 times 18.2. You can multiply that all out in the calculator. So 144 times pi, divide that by 180, multiply it times 18.2. And I get 45.74, and this would be, units would be centimeters. So I'd get the same thing by doing 72.8 times pi divided by 5. These are the same answer, okay? One is exact, so the pink is exact, and the one on the right would be rounded. So it would just depend on if you had a calculator for that kind of question or not. Say again? Yeah, it would be centimeters. I don't think WebAssign needs the unit, but if it did, that's what it would be, okay? And then the area, 1/2 theta times the radius squared. So 1/2, again, I'd have to have it converted. So I'd either use 4 pi over 5, or I'd leave it as 144 times pi over 180. And then r squared, 18.2 squared. So 18.2 squared times 4 times pi divided by 5 times 0.5. And you get 416.25 centimeters squared. If it was to keep it exact, I would just simplify what's here. I would square the 18.2, and then I would multiply out the numerators and the denominators, simplify what I need to. But on the homework, it will say round to 2 decimal places or round to the nearest hundredth, and so you're doing that. The only other variation of question you're going to see on the homework is like if I gave you, let's say you got the arc length and theta, but you didn't know the radius. So if I had my arc length was 45.74, and theta is that 4 pi over 5, and I needed to find the radius, I would just divide both sides by 4 pi over 5, or multiply by 5 over 4 pi. Okay, but on a calculator, it's easier just to multiply. To divide by 4 pi over 5. So you could be given the area or the arc length, and you got to work your way backwards to find what's missing. Just solve for your equation. Okay. Questions? Yeah.